So this Python linter, anyone who has this installed pretty much sticks with the convention of writing Python, no matter where they are in the world. So it doesn't matter if Justin is writing it or somebody in Japan is writing in Python. We can read each other's code because they all align with the same convention. JavaScript has the same thing. I think so, like ESLint. I don't have it installed. That's fine. Whatever. But these linters help developers stick to a convention so their code is readable throughout, no matter where they are. So if you don't have a linter, install Pylint. When we get to JavaScript, install ESLint. It's always good to have a linter because it also tells you about debugging and code and everything like that. So I'm going to clear. Let's talk about inheritance. We kind of did inheritance yesterday. You didn't have to do that. Like you could have, like in our so in our school interface, say Wednesday. Yeah. So we kind of talk about inheritance a little bit, but we don't necessarily force it. You could just have separate classes and your application would work fine. But let's talk about inheritance. Inheritance. So what do you think about when you think about somebody like inheriting something? Right. Perfect example. So I inherit I've got really curly hair when it gets really long. I inherited that from my dad, but I can't pass on attributes from myself back to my parents. That's just impossible. It always flows down. My blue eyes, whatever, like pale ass skin, that's from my mom. Yeah. So think of inheritance like a parent to a child. And when we're developing software, CD, is it desktop, kilo challenges, code. When we're developing software, we have these objects, these class objects that can inherit certain attributes from their parent. So in school interface, we had a person class that can inherit, their like name, like inherit. I'm sorry, we had a student class that can inherit certain attributes from a person class because all students are persons or people, and all staff are also persons or people. So let's see what else we can inherit from our parents. So inherit. So I'm going to create a class called dog. Dog.py. Open up some nodes. So all this stuff is also in, but where's inheritance? There it goes. Oh, I have to create a class called dog, so I got to touch dog.py, code, dog.py. So I have this class called dog. It's just a generic class. What's going on? Oh, lowercase c, thank you. Class dog. And when I initialize a new dog class, I just want to take in the name. That's pretty much it. Self.name. Name. But I also want other methods like self. I can tell as an application, I can self.eat or def.eat, and then I can return print I kibble def. I can bark self. It's going to return print bark bark. What other ones? We can do fetch. And these are default. Got this fetch, get the ball, passes in self. So pass the ball, the dog self.name says hi, hey kid, I'm a big dog. So if I wanted to create a dog class, like new dog instance, dog, well, Fido. And I can call these methods on these dogs. So I'm going to print new dog.name, and I'm going to call all these methods. Bark, eat, bark, fetch, size. I'm going to clear down here. I'm going to Python run this dog.py file. Oh, what just happened?
Are you printing twice?
I'm printing. So am I printing? Yep. Down here, clear again. Fido. So I'm not invoking these. That's why nothing's happening. Clear it out again. So I love kibble, bark, bark, get the ball, Fido. Hey kid, I'm a big dog. So that's like the basic methods of this class. But now we can get more specific. So we have like a person, like a human class. This is a dog class. Now we want to get down to specific, breeds of dogs. So I want to create like a touch lab, like a Labrador. So I'm going to code lab.py. I'm going to split the dog class out to here. So a lab will inherit everything from a dog, because a lab is a dog, but a lab is you want to get more specific, more granular to specific attributes of a dog, or of a Labrador. So we have class lab, and then we want to def init, just like we normally do. And in addition to the name of the dog, we want the size of the dog. And should we do something else? Yeah, no, that's fine. Now, in order to inherit everything from this dog class into the lab class, because we don't want to write all these methods for the generic dog class, because what if some of these methods, so when a lab barks, maybe his bark is a little different than just like a basic dog. We can, from dog, import dog. And just like before, in order to, we can do dog. Is that how we did that? Okay, if we use super, we can get all the dog value. So we call super, and we just pass in the name. And we also want self.size of dog. Dog equals size of dog. So in here in the super, it's going to should call, but there's an error already, I can tell. It's going to call, so we're actually not actually inheriting the dog class. In order to inherit the dog class, we have to encapsulate dog within the parentheses of lab. So all the attributes of dog are now available within the lab class. Yes, Justin.
Tom, with super on line 5, by specifying name there in the argument or parameters arguments, are you, if dog had more in its more items, are you like specifying the only ones that you want?
So this will probably throw an error, because when you do super, you're instantiating, you're literally just coming in here and doing an init, just like you're down here. And if you're not passing in all the arguments, the required position arguments, it's going to throw like a required positional argument error.
Okay. Well, I guess I'm just curious, like, what within the super init, what the requirements are, what the limitations are.
So you have to pass in all the parameters that you would normally pass in to the parent class.
But if you just did dog dot, you could pick and choose which ones you wanted.
So if you just call dog.init, like up here.
Yeah, for instead of super.
No, I think, I'm not quite sure. You might, if you just called it dog.init, I think it's only giving you access to the init. I'm not 100% sure. Yeah, I'm not 100% sure, but yeah.
Okay, cool.
So super, name, passing the name, size of dog. So if I wanted to create a new lab called Sadie, lab, gotta pass in the name. So Sadie, it's a big dog. And now I want to access Sadie's name. Sadie.name. I clear down here, and now I'm going to Python or run the lab.
Your Sadie's.
Thank you. Python lab, Sadie. But now, since I inherited all the attributes of dog, I also want to see here Sadie's bark. Bark. Clear. Bark, bark. But Sadie's bark is a little different than just bark, bark. Sadie's bark, or this lab's bark. Yep. Since it's a big dog, it's going to be a big bark. All right. Bark self dot return print big bark woof woof. So I'm down here. So my parent has the same attribute as a method bark, but I have the same attribute, but it's slightly different. Let's see what's going to happen. Big bark woof woof. So you can override your parent's attributes. What else can we do? Size. So right here, let's see the size of Sadie. Size. Come here. Hey, I'm a big dog. Hey, kid, I'm a big dog, but def size, self, print. So it's actually going to say the same thing. Very large, fat dog. So Sadie's a very fat dog. So return, print. I'm a very self. So I'm already describing. I'm going to get rid of that. Self dot size of. But I need to do string interpolation. Clear down here. So I'm a very fat dog. Yes.
What would you have to put in there? Like you could call though the other size from the parent, like we did with super.net. Like if you wanted to make that size have not only the lab's version of size, lab method size, but also call the dog size at the same time, so you can print both statements. You can just do a call to dog.size in your method for size there.
So in here,
like right before that one.
So yeah. Print, or so it would just be dog.
Be just
dog.size. Invoke it.
Yeah.
Let's see what happens. I've done that before. Oh, dog.size, missing one position argument, self.
You can probably call super.size.
All right, let's try super. Super.size. Clear. Yeah. So I'm in size method. I call super, which is my parents' size method, which comes into here, prints, hey kid, I'm a big dog, and then it comes down to here, returns, I'm a very fat dog.
Because you use super as part of the init, and you have access to all those methods anyway, though you don't need to use super necessarily, right? Or is that a better practice just to use that?
I'll just say dog dot. I just want to see if this works. So kind of going off on a little tangent, but okay. So you're saying
That way you could be running both methods instead of completely open. But because you're knitting with the super, which should give you access to all the methods anyway, it's a little
yeah, it's a little redundant. And if I don't know of an instance where you'd want to run, like where the lab would be totally different. Like if you want to run the same method but have different outcomes, then you'd probably just want to call this something else, another, like, yeah, like something else if you want a different outcome. What questions do you have about inheritance? So you have to import your parent. You have to encapsulate or pass in your parent attributes into your child, which is the lab. When you call your init, you want to run the super, invoke the super dot init, which is essentially going back to your parent, coming over here, and running the parent's init. You know, you have to pass in all the attributes. So as Ryan was saying before, what if this takes in another positional argument called, oh man, dot fur color, and I invoke a new Sadie. See what happens. Yeah, so missing one positional argument, fur color. Golden. Wait. So you have fur color, then down here, it's golden. Still not working because I have to pass in fur color up here. Clear down here in the terminal. So I create another positional argument. So you can't just pass in a certain number. Oh. Where's this coming from? Oh. Oh, right here. I see. Anyway. What questions do you have with regards to inheritance? Let's keep going. Let's do another one. CD, let's do an employee class. So touch employee dot py, and let's do a developer class. So everyone's an employee, but people have different positions at companies. So code employee developer. Copy this code over. So in this employee class, we have number of employees, which is a class variable. And it first name, last name, pay. First name, last name, pay. Then it creates an email address based off of the first name and last name. Makes it a lowercase. Then it increments the employee variable, I'm sorry, the class variable employee, number of employees by 1. Then right here it says, tell me about yourself. Great. So let's create a new employee. Tom equals employee. Tom. Create. And what's BH again? $2,000? Money. Or you said, someone said it was like 2,400 in the city. So Tom dot tell me about yourself. Invoke it. A clear down here. So I created this employee class, and it takes and pay. I've got this tell me about yourself, and it prints my name is Tom, read. My email address is self.email, and I get paid blank a year. Let's do month. So I come down here and create a new employee instance, pass in my name and my monthly pay. Tom, tell me about yourself. Should print out, so Python, Pythono, employee. My name is Tom Preet. My email address is tom.preet at email.com. I get paid X amount. So now let's go into a developer. What's unique about a developer? Class developer.
The language you use.
All right, perfect. Let's do that. Def. So in addition to being just a developer, I have a first name, last name, and I have a pay. So I need to first inherit everything from the employee. So from employee, import employee. Now I need to inherit all the attributes from an employee as into the developer class. So employee. Now I do def init, just like I do every class. Self. And what do I need? I need, was it first name, last name, pay, name, last name, pay, and then language. What language am I good at? Super. So this gives me access to all the employee attributes. I'm going to invoke the init method in the employee class, and I'm going to pass in Tom. 2400. Language is JavaScript. Wait, nope.
No, that's not all with that.
So an employee class doesn't accept a language. So down here, do self.language equals language. So right now, I can do, instead of down here, I'm going to create a new developer called Tom. Developer called Tom. Tell me about yourself. Let's see what it says. Oh, nothing happened.
Like instead of Tom, shouldn't it be like name, first name,
Yeah,
last name,
your super
and
init call.
in the super line?
I think you Pythoned the wrong file. It should be developer.py. Right?
You ran employee and your super init call is also not using variable names. It's actually
Say it one more time. Oh, I'm okay.
Name.
Thank you. Yep, staring at code for too long. All right, employee last name, great. And what else? So
and
employee.
you ran employee.py.
Okay. Python developer. Trace back there. Missing one argument. Language. So I don't have a language yet. It should be JavaScript. So my name is Tom Preet. My email address is tom@tompreet. I get paid X amount. But I also want it when someone asks me about myself, I also want to tell them what language I'm most proficient in. So self. Tell me about yourself. Self. Paid a month. So I program in self.language. So my name is Tom Preet. My email address is self.email. I get paid self.pay a month. I program in self.language. Clear. I run the developer. So my name is Tom Preet. My email address is tom@email.com. I get paid $2,400 a month. I program in JavaScript. We can change existing methods for the parent. Let's see how many employees. Let's do this a couple more times. Tom, Noah, Ruby. We don't really need that. But now I just want to print, can I do this? Employee dot number of employees? I don't even know. 2. So went straight to the class, grab that class variable, number of employees, and it's increased by the number of 2. because every time I initialize a new developer, it comes into the super init, which comes into employee, calls this. Every time I initialize it, create a new employee, a new developer, increases it by 1. Any questions? Comments? I'm going to stop the recording right there.